So this is a drilling milling head from a combination mill drill machine. So I've been asked to see if I can do something to improve the clamping arrangement of this column and the head. So if I tighten that quite tight, still nothing there. So to expect this to clamp this head, to mill something with this torque arm here, trying to turn it, pretty useless really. So when I measure this bore and I measure this column diameter, I find it actually has a diametrical clearance of 0.13 millimeters, which is about 5 thousandths. So there just isn't the precision really to make that effective. So I had a bit of a think about it, so what I've decided to do is to put in two clamp cylinders or split clamps in here, but because this has got this groove in, so this is the mechanism for raising and lowering the head, and there's both bearings in here and a radial groove in here. The clamp needs to be wide enough to really straddle these grooves. So I've decided to use some 1-inch diameter bar to make these clamps. The alternative would be to put one clamp, bigger clamp, maybe it's 1.5 inches diameter. But that's making the job more difficult. But anyway, I decided just to stick with 2 clamps, and that should make a big improvement. I've made up this boss to clamp on a cube plate, or a cube, I think you would call it a cube angle plate, I'm not sure, you'll see in a minute anyway. So that will give me a reference to locate on there, and a clamping plate on the other side. So I've prepared those 2 plates, and I've prepared a plate to go on the back. So the problem is, when I cut these inch holes in, there's just not enough material. So I've prepared a plate to clamp on there, so we'll have to machine this flat. Actually goes that way. I've pre-drilled 2 holes. I'm going to put 8 M8 bolts in and 6 M6 along the bottom. So I'll get these 2 drilled, get the plate on, and then I'll drill the rest in situ. So I couldn't go all the way down with that larger cutter, so I'm left with a radius at the bottom. So I'm just going to use a small cutter to take that out. I've pre-drilled the plate with the tapping size, and I've no way of clamping that on to hold it, so I'm going to hang it on the drill. So this is tapping size for M8, and I'm just going to get it into position. I'm just eyeballing it. See, we're somewhere close there. That seems to be it on the x-axis. And come down a bit. Okay, I've just drilled this hole 8.1 millimeters, so we can tap this bottom hole out, so the tap should fit in. So now I can just drill all the other holes with the plate in situ, so we get perfect alignment. So I'll just quickly do that off camera. Drilling done. So I've just cleaned the plate up a bit, and I'm going to Loctite it in place on there and Loctite the bolts in. Okay, so I'll just finish off putting all the bolts in. So that's nice and secure. So now we just need to remove the excess material on the sides. So that's the plate bolted on. Doesn't look very pretty, but it's effective. So this is one of the pins that we'll be making to clamp onto the shaft. So one will go in here, another one will go here. So they need to go, that'll go in flush with the edge of the head. So that's going to go down about 95 millimeters. So we'd be drilling in here where there's already a hole, and the centres are in a different position to each other. So this slot drill will only get me down to about there. So the actual hole actually goes right through almost. So all I can do is follow this up with a drill and hope that what's already been drilled with the slot drill gives the drill enough support to finish off the drilling. It's going to be unpleasant, but that's all we can do. So we'll get this mounted on the milling machine. Okay, so I've got the cube bolted down square to the table. I've got my locating boss resting on these parallels, so I can edge find the top of this parallel and get the position, get the spindle positioned correctly. So if I raise the table by half the diameter of the end of that, which is 4mm, so I need to come up 2mm, which is 79 thou. Okay, so I now know that the centre line of the spindle, or the axis of the spindle, is tangential to the locating boss. So according to my maths, I now need to raise the table 225 thousandths to get the centre line of the hole in the correct position. So 125, 150, 175, 225. Okay, lock the table off. Okay, we're all set to go. It's all or nothing now. If I mess this up, we'll have to leave the country. Okay, so that's a hole drilled out to 18mm. So now I've got to bore it out to 25.4 or 1 inch. So I didn't have any boring bars suitable, so I've made up a couple. It's yet another tool in the arsenal that you hope you can use on another job sometime in the future. But anyway, so I made this one 17mm diameter. So that should get me to a bore of 23mm, and I made this one up, this is 22mm diameter, but for this one I put in a 732 by 40 TPI thread in the back, and I made a little bolt so I can screw that in and I can make fine adjustment. So one full turn of that will remove the cutter 25 thou, so half of it will be 12 thou, say, a quarter will be 6 thou, an eighth will be 3 thou, so I should be able to accurately position the cutter as I bore out the hole and get it to a good size. So we need to be pretty accurate here, and everything needs to be a nice fit. Should be okay. Okay, so that hasn't taken as big a cut as I thought. We're at about 20.5. So I'll just adjust the cutter position to take another cut. Push it out a little bit. Okay, I'll just continue with this. And I'll bring you back when I'm nearly done. Had a scary moment where I nearly went over size. So we're actually at about 24.5. So I think I should start working in inches because it's a 1 inch we're looking for. Anyway, so I've put in the other cutter so I can now control the position of the cutter much better. So I've got it set to take a cut 12 thou in diameter. And I'm just going to keep doing that and measuring it, and probably the last few cuts will be 2-3 thou each, just to make sure I don't go over size and get it to as near the correct size as possible. We want a 1 inch bar to be a nice fit in there, so it's patient work, that's what it is. Patience, 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 a little bit at a time. So I'll bring you back when I've got that done. Okay, that should be on size. I've got a bit of 1 inch bar to try in as a gauge. That looks good. Pretty neat fit. I'll take the cutter out and try the actual component. Yeah, it's pretty good. Happy with that. Can't get it out now. That's a problem. Thank goodness for that. That's a bit of a tense operation. Got one more to do. I'll do that off camera. Bring you back when I've done it. Okay, that's the most difficult part done. It's turned out very well, very pleased with it. Pins or the bars are a very good fit. Second hole has got a slightly better fit than the first, but still happy with it. So now we need to scallop out the pins or the clamps with the radius. So to machine these clamp pins, I've made up a certain fixture. So I put an indexing hole in so that I can machine them, take them out, and then index them back in exactly the same place. Clamp them down. So the idea is to machine them somewhere close, take them out, try them in the job, and then 2 or 3 thou at a time, just machine them until at the right size, until they fit nice. So one way to do this would be to put it in the milling machine with a fly cutter set at the correct radius and just scallop them out. But I'm going to commit a sin, terrible sin, and do them in the CNC Mill. The advantage is it'll save making up a dedicated fly cutter. So that's them done on the CNC. So after the initial roughing pass, each one got 2 5/3 passes, and that made the one at the rear exactly the right size, but the front one was still a little bit oversized, so the front one needed an extra 4/3 taken off. So it's got an extra pass. So I've stamped them 1 for the bottom and 2 for the top so they don't get mixed up. And they fit in very nice. It's very slightly proud, but then there's a lot of clearance between the shaft and the bore, so that's probably a good thing, and the shaft fits in okay. Okay, so all that remains now is to drill and tap these for these cap screws, and then cut them in half. Well, cut them in the centre of this radius here. So I'll just quickly do that off camera. Okay, that's then done now. So I've made them so that when they clamp together there'll be about a 5mm gap. So I've spaced them so that when one is clamping, for example, on the crest of a groove, the other one is straddling the groove, so clamping on both sides. So I've spaced it half a pitch out. And these are made from 1-inch diameter ground silver steel or drill rod. So they're quite tough. This one's a bit of a tighter fit in the hole. Okay, just nip that up. Yeah, that's got a good grip. So just very lightly tightening those up provides a good grip. Of course they'll need to be tighter if you're using this for milling, but it demonstrates how effective they are. So if I slacken this one off, I've tightened the other one a little bit. Yeah, pretty good. I think job done.